Dear students, today we will learn a new unit. In this unit, we have three chapters. That is, the three chapters are Chapter 4, a review of trigonometric ratios. Chapter 5, trigonometric ratios of compound angles. Chapter 6, trigonometric ratios of multiple and submultiple angles. In previous class, in Unit 1, we learned about logarithms and partial fractions. So Chapter 1 logarithms, Chapter 2 partial fractions. In second unit, we learned Chapter 3, that is matrices and determinants. And in this third unit, the main chapters are 5 and 6. The fourth chapter is given basics. It is already covered in 10th class, maths, trigonometry. So now we will review that trigonometric formulas, whatever we learned in the 10th class. Here we just recall and we discuss about chapter 4, that is review of trigonometric ratios. So this is chapter 4, and trigonometry is a word derived from two Greek words, trigonon, which means a triangle, and metry, which means to measure. Therefore, trigonometry means the measurement of triangles, that is, which deals with the relations of sides and triangles of sides and angles of triangles. Originally, it was considered as that branch of mathematics which dealt with the sides and the angles of a triangle, but now it has a wider scope and we find its applications in various branches of science. Its applications. Trigonometry is one of the most important branches of mathematics. Some of the applications of trigonometry are, there are so many uses, but here few are given. Let us see. Measuring the heights of towers or big mountains. Determining the distance of the shore from the sea. Finding the distance between two celestial bodies. Determining the power output of solar cell panels at different inclinations. Representing different physical qualities such as mechanical waves, electromagnetic waves, etc. So, to know the uses, first we have to know what is trigonometry, what are the formulas, how to apply in problems. In latter, we can implement that formulas or that rules to find out these uses or applications. So next we will go to next slide. Trigonometric ratios. In trigonometry, trigonometric ratios are derived from the sides of a right angled triangle. There are 6 ratios such as sine, cosine, tangent, cotangent, cosecant, and secant. You will learn here to build a trigonometry table for these ratios for some particular angles such as 0, 30, 45, 60, 90. You already know these in 10th class. Till we will recall them. There are many trigonometry formulas and trigonometric identities which are used to solve complex equations in geometry. Here the concept of ratios of trigonometry is covered along with its definitions and applications. Trigonometric ratios definition. It is defined as the values of all trigonometric function based on the value of the ratio of sides in a right-angled triangle. The ratio of sides of a right-angled triangle with respect to any of its acute angles are known as the trigonometric ratios of that particular angle. Consider a right-angled triangle right-edged at B. Look here diagram. At B, we can see it is a right angle and remaining A and C are there. So AC is the hypotenuse and AB is perpendicular side and BC is a adjacent side. With respect to angle C, the ratios of trigonometric are given as sine. Sine of an angle is defined as the ratio of the side opposite, that means perpendicular side, to the hypotenuse. So simply we can say opposite side by hypotenuse is, we say sine A. Here A is the angle, so that's why I'm saying sine A. Like cosine. Cosine of an angle is defined as the ratio of the side adjacent to that angle to the C. Like this, simply we can say cosine is or cos C. Sorry, in earlier I told sine A, not sine A, sine C. We are saying respect to C, so sine C equals to AB by AC. That means opposite side by hypotenuse. Like cosine means cos C. Simply we can say cos C, or cosine C equals to BC by AC. Like this we can know tangent, cosecant, secant, cotangent. These are already in 10th class. The above ratios are abbreviated as sine, cos, tan, cosec, sec and tan respectively in the order of the. So for triangle ABC the ratios are defined as. So I already told you cos C equals to BC by AC. Simply like that we can define tan, cosec, sec, cot C also. In right angle triangle ABC, if angle A and angle C are assumed as 30 and 60 degrees, then there can be infinite right triangles with those specifications, but all the ratios written above for angle C in all of those triangles will be same. So all the ratios, any of the acute angles will be the same for every right triangle. This means the ratio independent of lengths of sides of the triangle. Also check out trigonometric functions to learn about each these ratios are functional in detail. So simply we have to observe the point is, observation point is particular angle or with respect to particular angle we are saying opposite side by hypotenuse. So is equals to sine particular angle. Next, trigonometric ratios table. So here sine 0 in place of C, if I took 0 degrees, then sine 0 is 0, sine 30 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, sine 91. So these are some important angles we have to remember, and we will use these angle values in problems like sine, cos, tan, cot, sec, cosec. These are. Let us see one sum or one question. If sin A equals to 3 by 4, calculate cos A and tan A. look here, 3 by 4 means sin A. Here mentioned angle A with respect to A. So opposite to A side is BC. So BC is 3 and hypotenuse is AC. So AC equals to 4. So let BC equals to 3K and AC equals to 4K. Generally we are assuming multiply with K. Then by Pythagoras theorem, hypotenuse square equals to side square plus side square. From that, one side square equals to hypotenuse square minus another side square. So by using that formula here, you can observe AB equals to, we got K into root 7. So cos A equals to adjacent by hypotenuse, that is AB by AC. So root 7 into K by 4K. K get cancelled, so root 7 by 4. So if you are not multiply with K, then also you will get. But here the procedure is given so that they taken K along with 3 and 4. So cos A value is this, and like tan A means opposite side by adjacent side simply. So BC by AB. So 3K by root 7K, that equals to 3 by root 7. Like this we can calculate. So this is the very important, as you know, in 10th class also it is came. So transform the angle or reduce the angle. So there are some rules. See this table, OX OY. So XOY is the angle 90 degrees, and each have your 90 quadrats. If four quadrants are added, we got 360. So here is a first quadrant is lies 0 to 90 and second 90 to 180, and third 180 to 270, fourth 270 to 360. So some rules are given. In first quadrant all are positive, in second sine and cosec are positive, in third quadrant tan and cot are positive, and in fourth quadrant cos and sec are positive. That means remaining are negative. So to remember, we can simply will give some code like all silver teacups. So or you can know all students 10th class like so. And one more important point is, suppose sine 120 is there, that means sine 90 plus 30 we can write. 90 means 90 plus means second quadrant. So in second quadrant sine is positive, okay, but at a 90 degrees, 90 plus 90 means sine transforms as a cos. So that is also important. Wherever 90 is there, sine becomes cos and cos becomes sine, tan becomes cot, cot becomes tan. Changes occurs when 90 or 270 is there. 180 and 360 degrees is there, then there will not change. But the signs are very important. The signs are according to these rules. Okay, don't worry. When the problem is, I think you already know this in 10th class. Till if you have any doubt when we are doing the problem, then you will clearly understand and the doubts will be evaporated. See here, one example is given. Find the value of sine 150. So sine 150 we can write 180 minus 30. I already told you 180 or 360 means sine will not change, sine as it is, but we have to decide the sign, is it plus or minus. Again we have to go for quadrants. So 180 minus second quadrant. Second quadrant means sign is positive. So write as a positive. So sine 30. Sine 30 value 1 by 2 from table. Like this remaining are also. So you can see and find out the remaining problems and do exercise problems. If you have any doubts, ask me at whatever.ramchandra@gmail.com. And one more thing, whenever you are going to see the video, please this related PPT you have to open in your mobile or system or laptop, whatever it may be. Then by seeing PPT you can listen or see the video. Why? Because sometimes the video may not clear. That's why I am saying you refer or see first or have near PPTs. So every video is along with PPT. Which topic I am saying, that on that topic PPT is prepared. So don't worry about clarity of the screen. Okay. Thank you.